So our functional expression now is Q equal to f of P. That is to say that quantity stands as quantity demanded or quantity supplied, and P stands as the price. So if we're going to give the equation or the demand equation, since according to the law of demand, quantity demanded and price are inversely related. So that is already giving us an idea that there is an inverse relationship, or there is a slope which sign is negative for the demand equation. So when the demand equation has a slope, or when the equation, linear equation, takes a negative slope, then it can be already understood as a demand equation. But when the relationship is direct, in the case of law of supply, according to law of supply, if the price increases, quantity supplied increases also. Or if the price of the commodity decreases, the quantity supplied decreases also. So here, the law of supply tells us clearly that the relationship existing between the quantity and price is direct. That is why, given the supply equation, the slope is positive. That is to say, quantity is equal to A plus BP. While for the demand equation, we state it in the form of equation as quantity is equal to A minus BP. Take note that the sign before the parameter B is either positive or negative, because the sign of the slope tells us of the kind of relationship between the two variables. And there are only two kinds of relationship between variables. Either the relationship is inverse or the relationship is direct. For the demand equation, the relationship between the two variables, Q and P, is inverse. And for the supply equation, the relationship between quantity and price is positive or direct. So we now have the understanding as to what the variable or the coefficient B represents. And again, it is the slope. Now, how can we measure the slope? We can measure the slope through the change in the dependent and the change in the independent variables. So how are we going to measure the slope? Always, because B is a quotient. There is that numerator and there is that denominator. The numerator stands as the change in the dependent variable, and the denominator stands as the change in the independent variable. Now, since we use quantity and price as the symbol or as the letters corresponding the dependent and the independent variable respectively, then we say that in computing the slope, the numerator stands as the change in the quantity, and the denominator is the change in the price. Again, the numerator is a change in the dependent variable, and the denominator is the change in the independent variable. So that when we measure the slope between quantity and price relationship, then the slope can be measured as change in quantity over the change in price. But how can we measure the change? The change is simply the difference between the new value and the old value. Now, we usually use a subscript of 2 for the new value and a subscript of 1 for the old value. So, if the numerator of a given slope measurement is the change in quantity, so the change in quantity can be measured as Q sub 2 minus Q sub 1. Meaning to say, if Q refers to quantity demanded, then quantity demanded in the second period minus the quantity demanded in the first period. And the denominator is the change in price, so that the change in price can be measured as P2 minus P1. P2 is the new price and P1 is the old price. So that is how we can measure the slope. So it is now clear to us as to what the demand equation, or as to how the demand equation is to be presented in the form of a linear equation. The demand equation is stated as A minus B P, where B is the slope and A is the value of the dependent variable when the independent variable takes a value of 0. The sign of the slope, which is either positive or negative. Positive if the relationship between the two variables is direct, and negative if the relationship between the two variables is inverse. Now let us have here the example of a demand equation. Let us suppose that the demand equation is given as Q sub D is equal to 100 minus 5 over 2 P, wherein your slope has a fractional value, or as a value, no, of 5 over 2. The numerator is 5, the denominator is 2. Notice that in this given equation, quantity demanded equals to 100 minus 5 over 2p, the sign of the slope is negative. So the negative slope clearly tells us as to what kind of relationship existing between quantity and price. And so we now say that the relationship is inverse. If we go back again to how the slope is measured, slope is measured as the change in the dependent variable over the change in the independent variable. The numerator, which is given a value of 5, and the denominator, which is given a value of p, okay, is what this 5 over 2 represents. So, that is to say, change in quantity is 5 and the change in price is 2. So, how can it be interpreted now? I would like to reiterate relationship. In a relationship, there is always a cause and effect. So always, or the stimulus and response. Between the independent and the dependent variables, the independent variable is the stimulus and the dependent variable is the response. So that The denominator, which stands as the value of the independent variable, and the numerator of the slope, which stands as the the numerator, no, which if we are to compute for slope, the numerator, which is 5, stands as the change in quantity, and the denominator of the slope, which is equal to 2, stands as the change in the price. Between the quantity and price, what that will change first is the independent variable before a change in the dependent variable can be observed. So that it is always logical to say that the first that will change between the P and the Q variables is the P, or the independent variable. So there should be change in the independent variable before a change in the dependent variable can be expected. Thus, if we're going to interpret the slope, which is equal to negative 5 over 2, it can be interpreted in this way. For every increase in price by 2 pesos, the quantity demanded decreases by 5 units. So here, I clearly stated that the first one that has changed is the price. And there is a change in the price by 2 pesos. And because of the change in the price of 2 pesos, the quantity also changed by 5 units. Now, because the slope is negative, specifying an inverse relationship, if the price will increase, quantity demanded will decrease. Thus, if the price increased by 2 pesos, quantity demanded decreased by 5 units. So that is how the value of slope can be interpreted. B, or slope, which is a value of negative 5 over 2, can be interpreted as if the price of the commodity increases by 2 pesos, the quantity demanded decreases by 5 units. Or it can be stated in this way. For every increase in price by 2 pesos, quantity demanded decreases by 5 units. Now let us also consider the value of A in this given equation of 100 minus 5 over 2P. 100 stands as the value of your A. And what does the value of A means? Or what does the value of A stands for? The value of A stands for the value of the dependent variable when the independent variable is equal to 0. So if price, which is the independent variable, is 0, quantity demanded will be equal to 100. Thus, A equal to 100 means that quantity demanded is 100 units when the price per unit is 0. Now, let us have here example of a problem. Let us suppose that we have a problem stated in this way. Given the demand equation, determine the quantity demanded of the commodity when the selling price per unit is 5 pesos. Since our demand equation is Q equals to 100 minus 5 over 2P, what we have to do to solve for quantity is simply just to substitute the given price to that given equation. Specifically, we have to substitute the value of 5 pesos to P variable of the given equation. Therefore, quantity is equal to 100 minus 5 over 2 quantity 5. Since we replaced P, or we substituted the value of 5 to the variable P. Thus, if we now solve through algebra this value of Q, we have Q equals to 100 minus 25 over 2. 25 because 5 times 5 is equal to 25. And the denominator is 2. So, 100 minus 12.5 will be the result. And therefore, quantity is equal to 87.5 units. So, that is, when the price is 5 pesos, how much the buyer will buy? The buyer will buy 87.5 units of the commodity. Now, let us have another example. Suppose that the price per unit is 10 pesos. So again, earlier, our assumed price is 5 pesos. Now let us assume that the price will increase from 5 pesos to 10 pesos. So the given price now is 10 pesos. Using the same equation, quantity is equal to 100 minus 5 over 2p. What then will be the quantity demanded when the price is 10 pesos? So again, by substituting 10 to the p variable in the given equation, we have now Q is equal to 100 minus 5 over 2 times 10, which is now 100 minus 50 over 2. The numerator of 50 is actually just a product between the 5 and the 10. So 5 times 10 is 50. Okay. So we can now continue in determining the quantity when the price of 10, and we have 75 units. Because 100 minus 25 is 75. So, quantity demanded therefore is 75 units when the price is 10 pesos. Going back to the earlier example, when the price is 5 pesos, quantity demanded is 87.5. But when the price increased to 10 pesos, quantity demanded decreased to 75 units only. So obviously, as the price increases, quantity demanded decreases. Okay. Now, what about if it is the price that we want to know and the quantity is given? So let us consider this particular example. Given the demand equation, determine the highest price when the quantity demanded is 0. So the given demand equation is Q equals to 100 minus 5 over 2P. And what is being asked is to know the price when the quantity demanded is 0. So algebra can help us compute for this. And of course, we can just substitute 0 to quantity demanded, since the value of quantity demanded is 0 as given in the problem. And now, we only have one unknown variable, and the unknown variable is P. So we have now 0 is equal to 100 minus 5 over 2P. And so, by solving P, we have to transpose. The negative slope will become now positive slope when we transpose it to the other side of the equality sign. So, bringing all the whole term to the other side, we now have 5 over 2P is equal to 100. So that 5P will now be equal to 100 times 2. So we multiplied 2 to 100 because the 2 came from as the divisor